Hi. In this video, we are going to look at a very interesting problem and a very clever proof. Like it is surprisingly short and beautiful. So, what is the question? So, this problem says, let there be given 9 lattice points in three-dimensional space. We'll discuss what a lattice point is. There are 9 lattice points in three-dimensional space, and they are asking us show that there exists a lattice point on the interior of one of the line segments joining two of these points. Basically, not much information is given. What is given is there are 9 lattice points in 3D space. So, first of all, what do we mean by lattice points? So, lattice points are basically points points whose coordinates are integers. Points whose x, y, z coordinates are all integers. So basically, any point can be determined in 3D space by our three coordinates x, y, z. And if all three coordinates are integers, then this is a lattice point, right? So the question has said that there are 9 lattice points in 3D space. And now they're asking us to show that no matter where these lattice points are, there is a lattice point on the interior of one of the line segments joining two of these points. So that is a very weird question because nothing further has been said about the points, right? So what we have, you can pick whatever points you like. So for example, I can pick random points like 1, 0, 1 is my first point. This is P1. I can pick another point 2, 3, -2. This is P2. You can pick 9 random points in space, right? The only condition is that the coordinates have to be integers, right? You can pick whatever coordinates 112, 0, 3, 3. I'm not even marking them properly. I'm just labeling random points and I'm saying you can pick any lattice points as long as there are 9 of them, right? And the question is making a very powerful claim, and they are asking us to prove that there is a lattice point somewhere on the interior of the line joining one of these line segments, two of these points. So, obviously, you can join these points in many different ways and make many different line segments from them, right? There are many line segments, there are basically 9C2 line segments, right? Which connect two of these points, right? The question is saying that there will be one lattice point somewhere on one of these line segments. One lattice point somewhere on one of these line segments. Okay. So think about the problem. It is making a very bold claim on the basis of very little information. Like right now, you don't know anything about the location of any of these points. You just know there are 9 points with integer coordinates in 3D space, right? So try and solve the problem yourself. If you want to try it out, just pause the video and try it out because the solution is very short and very beautiful. So let's get into the solution. So what I would say is there are 9 lattice points and each point has a coordinate like this x, y, z, where x, y, z belong to integers, right? That is the only restriction, correct? Now, what we will see here is we will look at the parity of these coordinates. What do I mean by parity? Parity basically stands for evenness or oddness. Evenness or oddness. So obviously these are all integers. So integers can have only two parities. They can be either even or odd, right? So we can list out what are the possible parities of these 9 lattice points, right? So obviously we know that x coordinate could be even or odd, y coordinate could be even or odd, and z coordinate could be even or odd, right? I don't care about the exact value of the numbers, I just care about the parity. So for each coordinate, we have two choices, even or odd, for thinking about the parity. And therefore, the total number of parities or parity patterns for these coordinates would be 8, right? Because you could have E, 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 you could have E, E, O, you could have E, O, E, and obviously I can list down many of them. E, O, O. I can list down 8 basically different parities, right? There are 8 different parities because there are 8 choices. 2 into 2 into 2, right? So 8 parity patterns are there and we have 9 lattice points, right? Now this should give you a hint. If there are 9 lattice points and 8 different parity patterns, then obviously by pigeonhole principle, two of these points, have the same parity pattern. Two of these points have the same parity, right? What does that mean? Basically, two of these points will be such that if you think of these parity patterns as boxes, there are 2 points in a particular box, maybe this box, and there are 2 points, P1 and P5 maybe, right? That is guaranteed because there are 9 lattice points and there are only 8 patterns. So 2 of them have to have the same pattern. And if these two have the same pattern, if P1 and P5 have the same pattern, that is, their XYZ are both even, even, and odd, even, even, and odd, then it is guaranteed that their midpoint will also be a lattice point. Midpoint of this will be a lattice point because it is guaranteed now that the sum of these will be even in all cases. Even if it was odd, 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 all three were odd, odd, odd. When you add them up, two odd numbers will become even, and that will happen. So therefore, the midpoint of P1 and P5 is guaranteed to be a lattice point. Because when you add up the coordinates, they will be even, even, even. When you divide by 2, it will still be an integer. It will not become a fraction, right? So I hope you appreciate how beautiful the solution is and how big a claim we are able to make from such little information. The only thing that was known was that there were 9 lattice points in 3D space. And we are able to say that there will be another lattice point on the midpoint of one of these 9 points. Line segment joining one of these 9 points, just because we got 8 different parity patterns and we had 9 points. So pigeonhole principle assures us that 2 of these points have the same parity, and if 2 of the points have the same parity for all coordinates, what happens is their midpoint definitely is a lattice point, because the sum of odd numbers is even. 2 odd numbers sum is even. The sum of two even numbers is also even, and since they have the same parity, it will always be a sum of either 2 even or 2 odd, right? So I hope you understand the problem and I hope you get the solution. It's a beautiful solution which employs techniques that you usually don't see all the time. So you usually don't think about parity so much, evenness and oddness, but it's a powerful technique, and also pigeonhole principle is a beautiful way to solve problems. So we have shown the existence of a lattice point here in this problem using these two techniques. Hopefully you learned something from this video. I'll see you next time in the next video. If you like the content, please like the video and also subscribe to the channel. That's a humble request from my side. Please share the channel with your friends and peers, and that will help me as well. See you next time.